So what we want to do now is read the question and underline key numbers. So what is the average speed? So I'm going to underline average speed, or I guess I could highlight average speed. Average speed, that's the quantity we want to solve for. So remember, the average speed equation average speed is equal to what? So see if you can write in your notes right now what the average speed is. But the average speed is going to be the total distance divided by the total time. So you need to pull those things out of the word problem. So as you're reading a word problem, you can be highlighting key important terms. So I'm going to look at my formula first, and I'm going to read. It says a helicopter flies 50 kilometers in 20 minutes, and then 30 kilometers in 10 minutes. And I'm highlighting those quantities. And total distance, well, if you look at the units, kilometers is a unit of distance. So we could figure out that the total distance then is the combination of 50 and 30. So we do 50 kilometers plus the 30 kilometers. The total time is 20 minutes plus 10 minutes. So in blue here, I'm going to underline our times. So our average speed is then equal to 80 kilometers, I just added, over 20 plus, this was a 10, so we had 20 here and 10 here for a total of 30 minutes. 30 minutes. So when we're looking at this problem, we now have 80 kilometers over 30 minutes. But the units in science for average speed, most of us are familiar with miles per hour. But in the metric system, we have typically kilometers per hour. So if we're going to do kilometers per hour, this 30 minutes is the wrong unit. We want it in hours. And most of you recognize how to convert, just even in your head. The kilometers is okay, but in science, we do kilometers per hour, not kilometers per minute. And so we need to convert that 30 minutes to hours. Well, 30 minutes is half an hour, so it'd be 0.5 hours. And so if we were to simplify this, if you take on your calculator and you do 80 divided by 0.5, 80 divided by 0.5 is 160 kilometers per hour. As you're working through this unit, when you report speed, you might do miles per hour, but typically in science, we don't use this British system. We use the metric system. We use kilometers per hour, or we're going to use meters per second to solve problems. So our average speed, I'm just going to put S for speed for this problem. You box your final answers when you show your work. Okay, you can pause this video and after you listen to this intro, I want you to try to figure out the average speed. So you're going to need to write down the average speed formula. Pause this video and see if from memory you can write down the average speed equation. All right, so the average speed equation is, write it down now, the average speed, this is the equation. In physics, we'll typically write the equation we're going to use first. And so we're going to take the total distance divided by the total time. Total distance divided by total time. And so when we think about this little lizard, he runs 100 meters, and then he runs an additional 50 meters. So the total time he runs is 100 plus 50. Notice the units have to be the same, meters and meters. If you're going to add quantities, they have to have the same unit. So in this case, we're fine. And then, how long does he take to run? What's his total time? Well, I'm going to underline those in a different color. I'm going to underline those times in red. His times are 40 seconds, so he goes 100 meters in 40 seconds. And then he goes that additional 50 meters in 20 seconds. So the total time is 40 plus 20, and that's in seconds. So notice that we have this convenient unit right now. Our unit becomes meters per second. And that, I said, was one of the measures of speed. It'll also be true for velocity. But in science, we either use kilometers per hour or meters per second as the unit of speed. And it actually happens to be true. It's the unit of speed or velocity. We haven't started talking about the difference yet between speed and velocity, but we will. So let's go ahead and finish this problem. So we have 150 meters divided by 60 seconds. You might need a calculator to do that. Sometimes for average speed, I'll just use the symbol S for average speed. And we'll use V for velocity. But the average speed then here becomes 2.5. If you divide 150 by 60, you get 2.5 on the calculator. 2.5 meters per second. Okay, so this problem seems easy enough. So we always write our formula first. They're asking us to calculate the average speed. A lot of times I'll have you underline what it is you're trying to calculate, and then you write out, for whatever it is you're trying to calculate, you need to write out your formula. So your average speed is equal to your total distance traveled divided by the total time. And so then what you're going to do, we use S sometimes for the symbol for average speed. And so your average speed, well, it tells you that you go 100 meters and that the time it takes in green is 2 hours. So a lot of you might simply just do 100 meters divided by 2 hours, and you end up with 50 meters per hour, which sounds great, but that's non-standard unit in science. In science, we want to use meters per second or kilometers per hour. So we have some conversion that we need to do. So maybe it makes sense to convert the meters to kilometers. So our speed then, we know that we know what the relationship is between meters and, so we know that a kilometer, 1 kilometer is equal to 1,000 meters. So that's our conversion factor. And so if we wanted to get rid of the unit of meters, cross that out and end up with kilometers on top, we want to end up with that kilometers on top, we need meters in the bottom. And so using unit analysis, pay attention to our units, we can cancel the meters and we'd end up with 50, but this is 1,000. So 1 kilometer has 1,000 meters in it. And so we get 50 divided by 1,000. We still have that 1,000 in the denominators. And we get kilometers per hour, which then simplifies to 0.05 kilometers per hour. So it seemed like a super simple problem, which in fact it kind of really is, but we have to pay attention in science that we're ending up with the right units. So our speed then should be 0.05 kilometers per hour. So box our final answer.